Alright, so this question here, we're solving this system of linear equations by substitution. So we're just learning about substitution here. So what we want to do is we want to find out what one of the variables equals as an expression. Okay, listening? So we need to solve for one of the variables in one of the equations. Now, the last example that we did, D was already solved for. You see that? So this extra step in this question is we're going to have to isolate one of the variables in order to start our substitution. So in this case, I'm looking here and I'm seeing that this x right here is all by itself with only a 1 as a coefficient. So I am going to rearrange this equation so that x is all by itself, because I want to find out what the expression for x is. And so that becomes this, right? I'm going to subtract 2y from both sides. And I'm going to get x equals, because this is going to be gone, what's x equal on this side? 2 minus 2y. Does everyone see that? Everyone see that? Okay. So write this down. So you're going to have to isolate for one variable first. Now why do we have to do that? Because substitution method says that I need to combine these two equations now. And if you look at this, I'm just going to move this back down here. Not sure why it's being silly like that. Okay, so now look at, see what x equals? I know that x equals 2 minus 2y. And so I am going to substitute that into the other equation. So this is going to go, where's x in this first equation? Right here. So everybody watching, this is super important. That expression goes into the other equation in for x, because x equals 2 minus 2y. So I'm going to rewrite x in the first equation as 2 minus 2y. And it's going to look like this. 3 times 2 minus 2y. Instead of x, I'm going to show what x equals here. And I'm going to come up with one equation. And look at this equation is now we have one equation and there's only one variable. So if you recall, we want one equation out of this with one variable. That's always our goal in substitution. And here we go, we've got that right here. Everyone see that? Yeah, you good? One equation, one variable, substitute. So now what we do is we solve for y. And of course you want to get rid of brackets right away when you can. So multiply this out. And we go 3 times 2. And 3 times negative 2y. So let's expand that out. 3 times 2 is 6. 3 times negative 2y is minus 6y. And I'm not going to touch this other stuff right now, so let's just show it. Rewrite it. Okay, it takes you 1.7 seconds to rewrite that. It's no big deal. Keep everything organized. Now I'm going to gather like terms. Here's some like terms right here. This y term and this y term. So let's gather those two. 6, what's negative 6y plus 4y? What does that equal? Negative what? Yeah, negative 2y, or minus 2. So 6 minus 2y equals negative 4. So we're getting close. Now I'll go a little bit faster. We'll get this 6 over to the other side. That becomes a negative 6 over there. Negative 4 minus 6. That's going to be negative 2y equals negative 10. We divide both sides by 2. And let's finish it up over here. By negative 2. And we get y equals positive 5. Does everyone see that? We solve for y equals positive 5. Are we good? Alright, so now we substitute again, but we substitute this y value into one of the original equations. It doesn't matter which one. This second one actually looks to be a little bit simpler. So why don't we just substitute the y value in here. So now x is going to equal 2 minus 2 times y, which is 5. X equals 2 minus 10. X equals negative 8. So it looks like so far we have the point negative 8, 5 as our final solution. Now, is that right? So you can go back and check your algebra, but another way to do that is to plug this point into both equations real quick and see if it makes both equations true, right? Or if you have a graphing calculator, you can go ahead and graph both these lines if you want and find the solution and see if it matches. But right now, since we're doing algebra, let's do an algebraic check and try and get this all on one page here. So let's see if -8 and 5 works for both equations. So 3 times -8, this is our check, plus 4 times 5 should equal -4. Let's just check that. That's -24 plus 20. Does that equal -4? Yeah, it sure does. So that's good so far. Now let's check the other one. What's the x value? -8. Okay. -8 equals, see, I'm on this one right here. -8 equals 2 minus 2 times, what's y? 5. Okay, so -8 equals 2 minus 10. Well, 2 minus 10 is -8. So we're good. So you can be pretty confident in saying that here is your solution right here. 8 and -5. So if we want to confirm that with the graphing calculator, this is what we do. You go to y equals, clear everything that's on there. All right, now we're going to have to isolate y to put it into the calculator. So again, this is just a review. Let's isolate for y here. So this equation is going to be 4y equals -3x minus 4, y equals -3/4x minus 1. Everyone see that? Does that look right? I'm going to plug this one into the calculator first. Actually let's use brackets. Bracket. -3 divided by 4, bracket x, minus 1. Alright. What about the other one? If I isolate for y for this one over here, I'm going to have, let's bring that 2y to the other side. That's 2y equals, let's bring this x over to the other side, equals 2 minus x, y equals 1 minus 1/2x. Plug that into the graphing calculator. So y equals 1 minus, use your brackets, 1 divided by 2 x. Okay, let's do zoom 6 to get a standard window and see if we can see the, oh, look at that. So here's the solution over here. Looks like it's going to cross over here. Does that look like it could be -8, +5? Could be. How do we check that? Really quickly. Second function, trace, gets you the calculate menu. Go to number 5, intersect. Is this the first curve right here, up here? Yep. Hit enter. Is this the second curve right there? Yep. Hit enter. There's only one intersection point on the screen. You can move your cursor over there just to be certain, and anywhere close. And then you want to guess. Yes. And look at that. -8, 5 is confirmed. So we've checked it algebraically, and we've also graphed it just to confirm. Okay? So that's your example solving by substitution. Any questions?